Hello and welcome to this edition of Global Climate Talk. I'm Guan in Beijing. The ongoing Ukraine crisis is sending shockwaves across global markets. It seems the development and utilization of new energy are more urgent than ever. And today we'll talk about a new alternative energy, the hydrogen. The role of hydrogen as a key decarbonization energy source is creating more buzz than ever. The emerging hydrogen industry is expected to attract growing investment amid increasingly stringent emissions restrictions. Meanwhile, falling renewables costs and developments into carbon capture and storage technologies are enabling more commercially viable green and blue hydrogen. Is hydrogen-powered future possible? Who will finance the hydrogen boom? What role should government play to incentivize markets? And to discuss these issues, joining me today are three distinguished guests: Richard Shaheen, Emeritus Professor and co-founder of Hydrogen Research Institute at University of Quebec. Welcome. And Joe Brusler, Executive Director of Plant Lifecycle Solutions and CFO of Linde Engineering APAC. Welcome to the show. And Leo Yang, General Manager and Executive Director of CIMC Enric. Thank you for your time today. So, Professor Shaheen, let me start with you. There is much buzz currently concerning hydrogen and its role as a key enabler of decarbonization. What are the advantages of hydrogen as an energy source?
Well, thank you for having me on the show. Before directly answering that question, let me just first explain what hydrogen really is and compare it to electricity. Then would be easier to understand the second part of my response. Hydrogen actually is like electricity, is not energy in itself. Energy comes from solar or wind or biomass. Electricity and hydrogen are energy carrier. They can translate that renewable energy, which is the sun, into a usable energy form for our applications. So electricity, like hydrogen, are generated either from fossil fuels, by burning coal, by burning natural gas like electricity, from biomass, or in a more less harmful way from electricity from solar and wind, So they are energy carriers. Hydrogen has to be made from either by taking water from substance, like using hydrogen from the water by electrolysis, or using the hydrogen from hydrocarbons and fossil fuels. Now that we made this definition of hydrogen, let's see why hydrogen is important. Electricity has been used from renewable energy. If it's used from renewable energy, it's a clean energy vector, and it's mostly used in transportation and mechanization. So it has been applied mostly to transportation, but if we want to decarbonize the whole economy, we need to decarbonize also other sectors, like the industrial sector, like the agricultural sector, and other sectors. And this could only be done by hydrogen. I'll give you some example, and then we will see what I mean by that. For example, hydrogen is used in fertilizers. Fertilizers are responsible for 3% of the global CO2 emission. If that hydrogen is come from clean sources, right, then it's 3% less emission. Steel production uses hydrogen. Refinery, they use hydrogen, a lot of hydrogen. Then if with that hydrogen we can make it from green energy, that's about 3, 4, 5% less CO2 emission. And that's very easier to do than transportation application. But then we can go further than that. All the hydrocarbon derivative, the plastic we use, the alcohol we use from hydrocarbons, they could be made from hydrogen if we can capture CO2. In this case, we don't have to capture. We capture the CO2 and use it to produce those hydrocarbon derivative. And on the long run, we can use hydrogen to make synthetic fuels, liquid fuels for airplanes and everything. They could come from renewable hydrogen and captured and use CO2. And all those applications, which are applied the whole cross-board of sectors of our economy, they can only be done by hydrogen. The buzz is real because we see the benefits of hydrogen.
Indeed, a very exciting future for the hydrogen energy. And let me take this to you, Mr. Boosler. Hydrogen is currently enjoying unprecedented political and business momentum with a number of policies and projects around the world expanding rapidly. Why is hydrogen energy a valuable investment opportunity right now?
Okay, thanks. Also my pleasure to be on the show today. And if you look at one of the big global trends now, decarbonization, right? And a lot of governments around the world agreed now to the joint goal to reduce greenhouse gas emissions to protect us from further global warming. Now that having achieved that global agreement on the topic that we want to reduce our emissions, now it comes actually to the point where we need to put the policies into action. And that's one of the big tasks globally to achieve over the next few years. And that's a very big field. Right? If you just think about the whole fossil fuel emission generating from, as Richard just mentioned, from transport to industry to steel making, cement, there's a lot that is related to that. And also agree here to Richard, it's not one technology. There are some easier to achieve quick gains, efficiency increases in industry, for example. Then we can electrify parts of industry, we can electrify parts of transport. But at the end, it's not one technology that can help us to go towards net zero in future. But there will be a lot of different technologies that actually we need to achieve that. And hydrogen also, we believe that's one of the technologies that can be really useful here as a clean source, actually. And if you then look at that, it's a good thing for society, the right thing for society to do. It's a global topic that we have, and it has a huge scale overall. So by doing that, we think that's a great field to be in right now.
Mm-hmm. And Mr. Yan, the just concluded Beijing Winter Olympics played a demonstration role for hydrogen energy. What's the market outlook for hydrogen in a wider range of applications, in your opinion?
Yeah, thank you for your question. And I think the success trial demonstration in Beijing Winter Olympic for hydrogen will bring a very positive promotion role in the future green industry. As what I would foresee, at least there will be 4 main areas for more usage of hydrogen in the future. One is to replace the traditional oil energy in the field of transport and logistics. Where in this Beijing Olympic period, I think there are many application trial of buses and car had been applied. So as we all know, with the fuel engine, the traditional oil fuel engine, the energy conversion rate can be as low as close to 30%. But the fuel cell, when we use hydrogen, the conversion rate to energy can up to 60%, becoming electricity. And when we calculate the energy conversion rate of electrical motor, then the efficiency can be up to 90%. So there is a very obvious great potential in the transport logistics. Given to current number in the country, in China by 2021, we already complete 230 filling stations on hydrogen. And then the licensed hydrogen vehicle are already close to 8,000. As per plan of our country until 2035, there is a plan to build up more than 5,000 hydrogen filling stations, 1 million of a hydrogen vehicle. So obviously the outlook in the transport logistics is promising. And second area, what I would looking at is the renewable energy storage. As we all know, in the country like China, the electricity industry contribute more than 42% of our carbon emission. And then within those electricity industry, and then 68% are coal-powered plant, electricity plant. And so the tendency in the future, a renewable green power grid with the natural gas as an emergency peak shaving power source is definitely will be the future. And then how to store the renewable energy. We will say the hydrogen will play a very important role in future. The third area where I would expect is the usage of hydrogen will bring the green alternative for many of traditional high carbon emission industry. Likewise, the hydrogen metallurgy in the steel mill industry. As we all know, when we replace the process of milling with hydrogen, they will also saving a lot of energy, also a lot of carbon emission. The last but not the least, what I will say also will be in future is a usage of a combined supply of coal, heat, and electricity, and also the electrical power. Those will also be an area where I can see the efficiency of the energy will be increased dramatically. So those are the 4 areas, at least I will say in the future.
Yes, look forward to all that kind of applications. And Professor Shahin, let me take this to you. Hydrogen is already with us at industrial scale all around the world. But today, most hydrogen is produced from carbon dioxide emitting fossil fuels. Its production is responsible for annual carbon dioxide emissions equivalent to those of Indonesia and the United Kingdom combined. How to further overcome barriers and reduce costs for green hydrogen to further unlock its potential in cutting our carbon footprint?
It's an excellent question, but I can correct a little bit here, not your numbers, but the conception of hydrogen. Okay, hydrogen uses fossil fuels for a reason, which is natural gas. But compared to electricity, and your guest just mentioned, electricity generation globally is responsible for 40% of CO2 emission, and we still use electricity as a transportation mean. So electricity is about 15 times more polluting than hydrogen. The point is the efficiencies of those technologies. There are so much higher efficiencies than combustion hydrogen, then it reduces the CO2 significantly, even if they come from natural gas or other sources. So hydrogen production is about 80 million tons a year globally, and then I agree with you. It produces like 800 million tons of CO2. But as your other guest mentioned, that now we are going through production of green hydrogen technology, and in the last 5 years, the electrolysis capacity global doubled over the last 5 years. And when I read the last IEA number, which is the International Energy Agency, we have about 400 new projects on the table for producing hydrogen from electricity. And if they are all realized in about 7 years, we will have had 10% of the hydrogen produced annually made from green electricity. That's about 8 million tons. But still is not enough. We have to accelerate, because if we're gonna go globally to a zero CO2 emission by 2050, you will see that from 8%, from 10% to 80 million ton, there's still a long way to go. The problem with hydrogen production is purely economical, because today, I mean, I'm not saying today, like yesterday, before this rise in prices, the production of hydrogen from CO2, for example, was $0.50 to $1 a kilogram, which is equivalent of 4 liters of gasoline. So, it's very cheap. But that is not true anymore, because we see today with the rise of gas prices, hydrogen production from natural gas has been multiplied by 4. So the kilo is going to 6-7 kilograms. And it's comparable now to the production of green hydrogen from renewable electricity. So as you see, there are economical factors, there are political factors, and then there are technological factors. So we now see that from solar energy, which has been now implemented practically all over the globe, we can produce hydrogen competitively with the one produced from natural gas. So we're going toward that road, but all what we need now is to accelerate the pace, because we have the technology, we have the economics, but the pace is very slow.
That's right. Well, indeed, a lot of factors are contributing to the rising capacity of clean hydrogen production. So, Mr. Boosler, Is a shift to a large-scale use of a hydrogen feed possible, and what's the pathway towards green hydrogen?
Okay, yeah, thanks for the question. If you look at where we're currently using hydrogen, it's mostly used in chemicals and in refinery. So with being able to use hydrogen as a green fuel and in other fields like in industry, what that comes along with that we need to increase the production capacity. And so we can do that from the traditional method by using natural gas and then using also carbon capture and storage to make blue hydrogen out of that. And also then for using scaling up renewable energy and electrolyzer to produce green hydrogen. So we do have those two sources to actually increase for the further future demand of hydrogen to produce more. And it's also hydrogen makes it possible to trade between different regions. And that also is a big advantage when it comes to centers where we can produce more and then other industrial centers that have higher demand for energy. And how about green hydrogen? If you think about 20 years ago and looking at the renewable sector, wind power, solar power was quite expensive at that time. But through the right policies and through continued investment and development, actually the cost came down to really make it competitive by now to produce electricity from solar and from wind. And what we're seeing now with all that interest in electrolyzers for the production of green hydrogen, we also see the same here that will happen over the next few years. More investment coming in, economies of scale, that means the cost is going to decrease, as well as the efficiency and the R&D keeps on going in that field. So the efficiency will go up, cost will decrease. Same will still happen on the renewable side. So overall, the economics here will just get better and better every year to also use green hydrogen in future in the coming years. And also, if you look here at China, also really happy to see that we have good investments here. We do have big green hydrogen projects in China already producing, and we do see a further announcement of big green hydrogen projects coming from solar, from wind power to produce green hydrogen. So there's a lot of movement in that field here as well.
Well, you talked about the industry reaching the point of economic of scale. How are these projects faring financially, or are they financially rewarding to them at this point?
Overall, it depends on what is actually the policy framework, but a lot of projects we're seeing is actually already that it makes sense to use electrolyzer for the production. So there are government policies that support that. There are also companies that go into that area. So it's a field where investment also makes sense going forward.
And Mr. Yang, let me take this to you. You've been observing China's industry development for a long time. In what ways can hydrogen aid China's decarbonization drive? What role will hydrogen play in China's energy mix as China striving to reach carbon neutral by 2050?
Yeah, I think it's a great question. I think I'm always quite excited about the potential future utilization of hydrogen and what kind of benefit the hydrogen can deliver to the benefit of the national decarbonization plan. As what I already just expanded in certain area of application for hydrogen. For instance, like in the electricity industry, as we all know, the whole country, the general rough number of CO2 emission is close to 10 billion tons. And then the Chinese electricity industry contribute 42%. So it's around 4.2 billion tons of CO2 is from the electricity industry. And 68% of those emissions are from the coal power plant. So if we can replace those with renewable, then think about the saving, of course, together with the hydrogen used as a storage wave method for the storage for the peak shaving energy, then this will make this a lot of sense. It's just from the electricity industry. Meanwhile, also, I did mention about the steel mill. In China, the steel mill industry also contributes about 19% of our carbon emission. So it's just less than the electricity industry. And together with carbon coke, which also will contribute around 464 million tons of CO2. So if we are able to, in the future, promote the hydrogen metallurgy technology to be fully promoted and utilized, then we will be able to expect a reduction of CO2 emission close to 80% in this industry. So it's very exciting. Last but not the least, just even in the transport and logistics, the car, mobility, the ship, vessel, airplane, actually in China, there are around 1 billion ton, which 10% of carbon emissions from transport and logistics. So in those areas, we can say particularly like medium and heavy commercial vehicle also contribute close to 47% of those carbon emission for the cars. So the conversion from diesel truck and from oil truck car into hydrogen truck and the vehicle will certainly benefit great. And here actually I also like to take the chance to introduce an investment we made together with Ansteel. It's a steel mill, I would say the third biggest in the country, in the North China. So we had a plan to, we made a joint investment with Ansteel. So we will utilize the waste gas of the steel mill production, which is a coke oven gas. So the traditional way of disposal of the gas, they would just throw away or maybe purify a little bit or burn it for electricity. So this is traditional way. And then the latest project we did with them, with our latest technology and equipment, we will convert those coke oven gas into natural gas, into hydrogen. So the phase one production will be able to deliver in North China, close to the steel mill, around 100,000 tons of LNG, liquefied natural gas a year, and then also 30,000 tons of hydrogen a year. And then by this conversion, we call it of a traditional COG, coke oven gas, into clean energy. So we also have a joint plan together with Ansteel, the steel mill, to change the traditional diesel oil truck into LNG truck and into hydrogen truck. So the steel mill factory plant where we invest very close is around 50 kilometers away from the port. So it's a very dedicated route of transport. So every day, close to 5,000 trucks transport raw material in the mill, in the factory, and then transport back with the finished product. So the plan, we will convert all those 5,000 trucks into a clean energy truck. So to achieve so we'll be able to save just for the transport and logistics 500,000 tons of carbon emission a year. So what we can see here, although bit and bit, but it's very much excited for the future we can looking at.
Indeed, remarkable progress in the industry. And Professor Shaheen, the hype about hydrogen isn't new. There have been several waves of popularity for hydrogen and also many failed attempts. I know you have been involved in the research of the area for a long time. Despite all its advantages, obstacles are also obvious. In your opinion, what's different this time?
About the hype first, as you mentioned, we founded the institute about 25 years ago, now almost 30 years ago, and we had many cycles. Believe me when I say most of the hype and the deception are caused by politics, because government come and they promise things, and then they promise some, they put some programs there, but they put some very short-term program, but then they forget about them, and then sometimes they don't do it, whatever. But this time, as I explained, the hype is for real, but in my opinion, it's not the last hype. We'll see other hypes, but the reality of it is that mainly two things happened since the last hype, if I can say, or the last cycle, as we mentioned, is after we tried all the electrification of transportation, and as government invested billions and billions of dollars in supporting electric vehicles and everything, and we still CO2 is rising. So the approach of the government by massively investing in one technology they realize that after 10 years or 5 years or 7 years of investment, they still CO2 is going up. So they have to go to hydrogen because, as you mentioned by previous guests, about China, they are decarbonizing steel industry, they are decarbonizing cement, they are decarbonizing fertilizer. Transportation alone is not enough. So, and then we realize also CO2 globally is increasing because of that. So we have to do something. And that's why, and technological advances are happening. So using green hydrogen now is not a fantasy with the coming of solar, which thanks to China, because before China started producing solar panel, we were paying, the solar was costing like 10 times more, but with China introduction of cost-effective technology, now make us easy for us to make greener hydrogen. And as I said, also is we are using it in a smarter way. It was very difficult to apply in the transportation because storage of hydrogen is still some bit of a problem for transportation, but using it directly in industry and producing it directly in industry, we avoid this storage problem, and then we can do very good efficiently without having to go to the obstacles which you talked about, which is always going to be probably mainly transportation and storage of hydrogen for now. But if we use it on site to decarbonize industry, that obstacle is kind of overcome. But also, as I said, we are going, the electrolysis is going full throttle, but still we might have problems. But in my opinion, and as a scientist, because I'm not a businessman, the really big game changer will come when we change the way we are producing hydrogen. Now we are using electricity as a medium to make hydrogen. And we need green electricity, which is from solar and power. So we have to invest lots of money in solar and electricity generation. We have to invest lots of money in electrolyzer generation. I mean, numbers are huge, like $1,200 billion are needed to do that. So that's kind of obstacle is what we call the initial investment in hydrogen project, which is the CapEx. It's a huge load in industry, and industry would like to do hydrogen. They have to invest lots of money in the beginning of the thing. Now their research are advancing on a different level. It's just making hydrogen direct from the solar energy, directly without electricity. And research are advancing very well, and that is called water splitting or photoelectrochemical, which is mean the same kind of semiconductor that the Chinese government or scientists developed to use in solar panel. We can use those kind of same material, put it in water, and under the sun rays, the sun split the water and have the hydrogen molecule at high efficiency. All right, that's a big game changer because we produce hydrogen directly without the need to big capex investment. So now the research is only advancing. We have the semiconductors, they are all the same, that the one from the solar power, but those ones, they have to be immersed in water, okay, because to split the water. And then the water ambiance is a little bit corrosive, so those catalysts, they are not surviving very long. So scientists are working on increasing their lifespan. If they succeed, I'm sure they're going to succeed, but when they succeed of doing so in probably 10, 15, 20 years from now, that would be the whole game changer, because then hydrogen would be the main intermediary between the solar and all other applications. Electricity then could come from hydrogen and not from solar panels or wind energy. When this comes, the whole picture would be a completely game changer, and I hope at that time we'll finish with the hypes of hydrogen.
Wow, a game changer indeed, and that will certainly bring us a more secure and sustainable energy future. And Mr. Büssler, the number of countries with policies that directly support investment in hydrogen technologies is increasing. We have seen initiatives by China, India, many other countries. What's the future for hydrogen energy market amid rising threat of climate change and energy crisis?
Yes, so we do see over 30 countries now that already released their hydrogen roadmaps. And industry has announced hundreds of projects in the field of hydrogen now. Governments put in billions of dollars in public funding as well. So that's a great point where we're at right now, from here to have a faster development of hydrogen in the coming few years. And if you look at the policies, they're different though in different regions. When you look, for example, as Australia is now positioning itself also as an energy hydrogen exporter. So Australia has a lot of resources. If you look at solar power, wind power potential, natural gas that can be used for blue hydrogen, so that production can exceed the needs in Australia actually for hydrogen. And Australia is partnering with other countries that have less such solar, wind and gas resources, but that have a high demand for energy as well. So you see, for example, in Korea, which is very advanced in working with liquid hydrogen, in rolling out hydrogen for transportation, which is partnering. So you see companies from different countries, governments partnering together to actually make big projects happening, which is difficult for one company or one country to do, cooperating between using Australia to export into Korea. And also in Korea, we're working with a partner, Yusung in Korea, for investing in liquid hydrogen plant, as well as in the hydrogen refueling station infrastructure in Korea as well. So if you say future of hydrogen, the mix will be quite interesting. So it will be in future an integral part of our energy mix. And you will see it in transport, you will see it in power, in different industries, the applications, and that on a global level. And more of that will come from green hydrogen as well.
Mm-hmm. Well, absolutely. Financing is key to the industry's development. What is your observation of the financing needs of the industry? Do you think we have enough financial resources to meet these investment needs?
So the needs, also the capex overall to have that energy transition, there's a big need for investment, and that is, it's not one company that does it alone. It's also, you will not see one local government doing that whole investment. We see a lot of cooperation here, different technologies, different partners, different investors coming together to make that all happen. That's a very big amount, but we also do see the increasing cost of emissions, of emission trading schemes, for example, that make the fossil fuel-based emitting sources actually more expensive. So with that, also the financing comes more available for green hydrogen projects for the energy transition here.
Right. And Mr. Yang, let me take this to you. What are the advantages and challenges of developing hydrogen energy in China?
Okay. So about this hydrogen development in China, from my understanding, I think there are a few good advantages when we develop this new energy into a country like China. First, from the country point of view, there are very strong support from the government, particularly our Chairman Xi, for our national policy of 30-60, which means that by 2030, we reach the peak of carbon emission, and then 60 to bring it neutral. So it's first time in the past ever the hydrogen have been writing into the 5-year plan of the country. And then both the National Council and a lot of national relevant ministry issue all the regulations, new policy to support. And as far as now, already 29 provinces already promoted their development plan for hydrogen, also for fuel cell vehicle, hydrogen fuel cell vehicle in the future. Meanwhile, the country also are promoting 6 large city clusters to jointly promote the whole industry, the industry chain of the hydrogen, which including the cluster of the Beijing, and Beijing, Tianjin in Hebei province as one group, and also Shanghai in the Yangtze River Delta, and Guangdong as Pearl River Delta, etc. So only in those 5 big group of city clusters, the plan is to promote at least 40,000 hydrogen vehicle till 2025. And meanwhile, there are a lot of policy and also subsidy being promoted into this direction. So I would say to promote the hydrogen in the country, China has received a lot of attention, a lot of support from the government. So the support from policy is very strong. And second advantage, I would say, is obviously in the country, whenever when we do those demonstration trial application, including this Beijing Olympic, including what we just explained it, report shared about our project jointly with Iron Steel. So each demonstration is big scale. Yeah, it's not just big scale, it's from upstream to downstream. In our project in Iron Steel, start from production of hydrogen, and then utilization of hydrogen in truck, filling station, and then the 5,000 truck just about to consume all the hydrogen we can produce. And also even in Beijing, of course, Enric ourselves also produced a filling station, transport truck for hydrogen. So the buses, filling station also will produce a module to convert methanol on-site in the filling station into hydrogen, and then with the CO2 catched by CCU technology. So all those demonstration from upstream, downstream, and also it's large scale. When those application and scenarios in large scale, then it will attract more I would say market point of view and promote the market and application, and then increase economic of the industry in great scale. Mm-hmm. Yeah. And then we can say recent year, no matter the fuel cell, the cost for fuel cell, the cost for transportation vehicle, the price are all coming down. So which will make the application more economic. Yeah, the same as the production of hydrogen. And meanwhile, the latest, I think the latest policy the country adopts, which is they promote the mileage rewards. So it's not just in the past giving the subsidy for new energy vehicle, like the electrical vehicle. That's the way how they do it. Every car you buy, you receive how much. And now it's more about the mileage. So the high hydrogen truck or car have to travel so far distance before they can receive subsidy or rewards. So actually, this is more accurate stimulation program. By doing so, I would say this secured quality growth and promote the real R&D of the whole industry. Yeah. So this is also, as I would say, very strong motivation for the whole industry, from upstream production of the hydrogen, transport logistics, filling, and all different modes of application in car, in ship, and then in renewable energy store, are all fighting up to the best technology. So this is also very motivated. And then the fourth, I would also think, as you just mentioned, the public financing. In the country, with the support first, the initial funds were from the government. And then meanwhile, we can say the public financing or the social capital very much support and then follow the direction of this new trend of the technology and new trend of future energy. So the support on this strong support from financial wise, also they giving this industry great advantage, particularly to apply in the country like China. But of course, there is also challenges. I would say challenges were more on the regulation. Anyhow, hydrogen is new, and then a country like China, comparably, we will be more conservative in in losing the regulation or losing the time for innovation, because safety always at the top of priority. So this I won't call it as a challenge, as an obstacle, but more a challenge. The industry need to work together to overcome and then to improve our regulation to be more supportive for this direction of innovation. Thank you.
Indeed, so solid support from multiple fronts. And Professor Shahin, you talked about the technology and new innovations. What more can be done by policymakers, and what more can be done through international cooperation to accelerate the growth of hydrogen economy?
This is the most important question now. I mean, after we said everything, so there is need to innovation, but innovation, we need to accelerate the innovation pace, because the innovation pace is not going as fast as we would like it to. So there are several critical new energy technology, as your guest has already mentioned, but the improvement, the efficiency, and lowering the investment for those technologies are not going full speed as they can potentially go. One of the reasons also is the lack of international collaboration between government and scientists, because we have lots of structure for collaboration on hydrogen, but there is no money in there to facilitate those collaboration. So international collaboration is a key. Acceleration of innovation is a key, because as I mentioned a while ago, this water splitting technology, I mean, it's done by universities, but there is no concentrated effort from like before, where government were spending lots of money on nuclear fusion, on other big technologies. That could be accelerated. And mostly government, they promise money, but it's so little. I'll give you some numbers and you'll see for yourself. Okay, all the world government now with their roadmaps and everything, they only committed $37 billion to hydrogen, $37 billion. The industry has already committed $300 million, which is almost 10 times or 7 or 8 times larger than the government. Mm-hmm. But what we really need is $1,200 billion. That's the real need to really make hydrogen a key enabler of zero decarbonization by 2050, as the government themselves decided that in 2050 they'll have zero carbon emission. So if you really want to do that, and you know the need of $1,200 billion, why are you only spending $37 billion? You make a policy, but then you have to put the money behind it. Otherwise you're not serious. This is my point. We government have to be ambitious to support their policies, because it's not an easy tax. We cannot from one day to the other eliminate the use of fossil fuels with a magic thing with $37 billion. Are we kidding? In this sense, I would like to see, as I said, a more ambitious goal from the government. And to just give you an example, China, I love China in a sense, because they are now, their renewable energies development is bigger than the total global renewable energy development. So China is doing something about it, but other governments are making policies, but they are not putting the real money behind it. So we really need to, I repeat, we really need to be ambitious as a government, do it internationally with international collaboration, but put the money where the needed money to do what you want to do, actually. Because if you do always make, I've been through, I don't do roadmaps anymore myself. I've done 7 or 8 of them. You know what I mean? We do the roadmap, then 3-4 years later, we renew the roadmap, but there is no money, you know, to execute the roadmap. Roadmap are nice, but you need the resources to do so.
Indeed, I think some long-term planning and forward thinking are needed here. And Mr. Boesler, what technology and expertise are being developed by Linde to further unlock the massive potential of hydrogen?
Yes, thank you for the question. At Linde, we actually been working with hydrogen for over 100 years. Our founder, Dr. Karl von Linde, was pioneering in the hydrogen energy industry. And since then, we've been working with hydrogen in industry since many years, from production of hydrogen to purification, to liquefaction, to transport, as well as downstream applications. So we do have technologies which are good mature technologies now in gray hydrogen and blue hydrogen with carbon capture and storage, and as well as in green hydrogen. And let me give you an example for applications more on the downstream side. We do have a product for hydrogen refueling stations, which we already built over 200 stations globally. And the speed now is picking up very quickly for further building and investment in hydrogen refueling stations. Also here in China, we're actually building the stations locally together with our local partner, Bingshan Group in Dalian, hydrogen refueling stations here in China. So that's also interesting to see different applications that were involved that have developed quickly over the last few years. Now overall for hydrogen, there are a lot of different needs wherever we look globally. Different projects, different environments have different needs to solve for different industries, for transport. And we do have a lot of engineers that have lots of experience in hydrogen and that develop the best setup, the best solutions for each project. No matter if it's using the in-house technologies that we have, but also partnering with other companies to overall make it possible to use hydrogen on as many projects as possible and to speed up that rollout here.
Thank you. And Mr. Yang, last question for you. Infrastructure and supply chains are keys to hydrogen's future. You talked about filling stations, 5,000. That is very, very ambitious, but more needs to be done. What is CIMC Enric's future roadmap to boost hydrogen business?
Thank you. I think from CIMC Enric point of view, I think actually not as Linda, but anyway, in the country, we're already in the hydrogen more than decades. And then the first filling station, like in Shanghai Egg Expo, is supplied by ourselves. And then, so our plan in the future, as what you said, the infrastructure is very important. I think what we're good at is, of course, from the manufacturer. We're very strong at the transport of hydrogen, no matter high pressure or cryogenic type, which means low temperature mode. Transport, storage, and filling, which is why we already quite strong in the market. And in the same time, and in this market, on the cryo transport storage of hydrogen, we are one of the earliest companies in the country produce those equipments. On the high pressure wise, we have now type 2, type 3, also the type 4. We have a joint venture with a Norwegian company to provide the type 2 cylinder for the industry. And meanwhile, we also supply from the production of hydrogen. We're quite good at from coke oven gas, from coal to hydrogen. Meanwhile, we are now investing in electrolyzer, from methanol to hydrogen, all those process, as well as on the end utilization. On the utilization point of view, no matter the utilization in mobility, in vessel, and also in those coal and heat and electricity combined production. Those are where we're going to invest. And we will focus on supply the key equipment and then core technology. And meanwhile, we also tend to invest for some particularly application scenarios, where like the unsigned steel mill case, where we believe by those investments, we might involve a little bit of handling the hydrogen, but the purpose of invest is to promote the whole industry and to demonstrate the best equipment, the best solution for the industry. So those is our roadmap for the future, and our mission is through the innovation of technology, through the R&D of our product. And what we want to do is we want to, through our efforts to make the clean energy, the usage of clean energy will becoming more safe and more cheap, more economy, and more widely applied. So those will be our dream and our aim, and we sincerely hope and wish our efforts will contribute in a good way and a good portion for the national 30-60 policy.
Indeed, look forward to that. Well, thank you very much. We have to leave there. Thank you all for your great insights. Richard Sherheim, Emeritus Professor and co-founder of Hydrogen Research Institute at University of Quebec. Joe Busler, Executive Director of Plant Lifecycle Solutions and CFO of Linde Engineering APAC, and Liu Yang, General Manager and Executive Director of CIMC Enric. And that's all for this edition of Global Climate Talk. Until next time, bye for now.